So, hello everybody again. So, in our previous video, we discussed what a CubeSat is and, all the functionalities we have on a satellite. On any kind of satellite, it could be a billion-dollar satellite or it could be a CubeSat. And all these have 5 components, right? We have always some power supply, which is, solar cells typically for a low Earth orbit satellite or anything that goes, close to the sun. We have a computer with software that's important. It's like in your smartphone, right? Without the software, without the computer, it wouldn't work. We have a radio because we need to communicate. We need to receive signals from Earth, from our ground station, and we have to transmit them. And in order to do this, we need a radio and we need antennas, right? And the other thing we are dealing with is an attitude control and determination system that tells the satellite how to go, where to go, and it tells the satellite also, it tells us where the satellite is in space. And then last but not least, we talked about the payload, which is the reason why we fly the spacecraft to begin with. And this could be, some relay station for a telecommunication satellite, or it could be some science experiment that I showed you in the last time with CXB and with the X-ray satellite. Now, the satellite behind me here is the model of Lunar Ice Cube. And Lunar Ice Cube, well, Luna means the moon, right? Luna, the Latin word for the moon, means that this will be a mission that will be going to the moon at some point, and it will go on the Space Launch System, the most powerful rocket NASA has ever built. And when NASA flies astronauts to the moon, before NASA can fly astronauts to the moon, what they have to do is, well, they have to test the rocket. They have to test the spacecraft, the Orion capsule, to make sure that everything is safe so the astronauts will survive it when they come back, right? Otherwise, you don't want to. Same thing when you buy a car, you make a test drive first before you actually buy that thing. So the same thing here. So when NASA launches the SLS in a couple of years, then NASA will also take 13 CubeSats on board. These 13 CubeSats will be hosted in a connector ring in the SLS that connects the main stage of the rocket with the Orion capsule on top. And one of these 13 CubeSats will be Lunar IceCube. And this model over here that I have here, is actually a one-to-one model. It's not the real thing. It's this time, I don't have the real satellite here. The real satellite doesn't even exist yet because we don't have all the parts yet at this point. But this is a one-to-one model that shows you the size. So it's about 37 by 23 by 10 centimeters large. And this is what we call a 6U CubeSat. The last one I showed you was a 2U CubeSat, but this one is 6U. And it's a little bit in 6U actually on steroids. But again, it has all the components, right? So we have power supply. So there's the power supply in the background. These are the solar panels. There are batteries here. There are the batteries. We have, of course, a drive. This is the drive that we can use to move the spacecraft in Earth's gravitational field. And we want to get to the moon, right? Because the rocket only gets us to about 1/3 of it. And then from there, we have to make our way to the moon, which is actually kind of tricky because this drive is not that powerful. Because up here is our tank, our fuel tank, and that contains iodine, and only about a kilogram, a little bit more than a kilogram. But this fuel is not really sufficient to bring us actually all the way to the moon. However, we can make it by using basically a super interplanetary highway that uses Earth gravity and the gravity of the moon. So you basically swing out of the potential of the Earth, swing back again, and then get to the moon. So that's our drive. We also have a star tracker, so this is our attitude determination system. You also have gyros, so there's a reactor right behind this thing over here that makes the satellite move, and we have 3 of them, so we can move the spacecraft in all 3 directions. It doesn't work with a magnetotorque simply because we are not in the Earth magnetic field, so we need something else. We need gyros, and gyros have been worked on many, many spacecraft. The spacecraft I was working on before, Swift, uses that in particular because it's used very, very fast. Here's the radio. That's one of our radios. That's an X-band radio, so that works at about 8 gigahertz. Then again, the star tracker. We have some electronic boxes, so computers, of course, on board. And then also now very important, this is our camera. This is our payload. This is an infrared camera that does spectroscopy, infrared spectroscopy. Now, why are we doing this? Well, what we want to study with the satellite in particular is we want to study the mechanism of water transport on the moon. This thing is kind of heavy. The real thing is about 14 kilograms. This is, of course, not lighter because this is all plastic, right? So what the satellite is going to do is we know that water exists on the moon, believe it or not. There are water deposits in the craters on the north and south pole of the moon. And we know water exists there, and we need water. We need water for the astronauts because the most important resource that you need is water, because you cannot survive more than 2-3 days without water. You can survive without food, that's unpleasant, but you cannot. Then the other thing is, well, we need oxygen, right? For astronauts, for your life, you need oxygen. And in order to do this, in order to get the oxygen, where we can split water into hydrogen and oxygen, and not only that gives you hydrogen, oxygen for breathing, well, it also gives you hydrogen, oxygen, and there's your rocket. But what we don't understand is how this water actually got to these poles. That's kind of weird, right? Why is it getting there? Well, what our understanding is, well, you have water from comets. If a comet is crashing on the moon, well, comets are primarily made out of water ice. And how does this water ice get from, or this water, how does it get from the equatorial region of the moon to the polar regions? We don't know. The other thing is an interaction with the solar wind, where you have oxygen from the rocks of the moon and you have hydrogen from the solar wind. And when they interact, well, guess what? Hydrogen plus oxygen is what? It's water, right? H2O. And we want to understand this. And that's why with Lunar IceCube, what we are going to do is we will be in a scientific orbit, a 7-hour orbit. And then for 40 minutes, we will look for the signs of water with our spectrometer here. And we will look for hydroxyl. We will look for, traces of water. And we will see how this correlates with different geological formations on the moon, how this correlates with the different time or night of the moon, and how this depends also on your latitude on the moon. And that's the goal of the spacecraft. Again, it gets assembled right now down in our clean room. I have another video on the clean room as well, so where I explain what's going on in the clean room. And this model should be done, this real thing should be done within a year or two. We don't know yet when the launch of the SLS is anymore because, again, because of the coronavirus, everything has been delayed. All the NASA centers have been shut down. The SLS is delayed. The Orion capsule is delayed. But eventually we will get there. We will get to the moon, and this will be Morehead's mission to the moon. How cool is that? And then in one of the next videos, I will talk with you guys more about, again, the clean room. I will talk about the testing stations, and then also about what is behind me here is the control room, because, again, you need to communicate with the satellite. Otherwise, what should the satellite do with its data? It's pretty useless. Like the same thing, you take photos with your camera on your smartphone. If you cannot transmit the photos on your smartphone somehow, well, then it's pretty useless. You can look at them on your smartphone, but that's it. You cannot send it to anybody if you don't have a radio, if you don't have, so to speak, a ground station. So, and with this said, well, I meet with you guys the next time, and have a good one. Bye.